So when we're doing machine learning, we keep hearing one word quite frequently, and that's vectors. So all your algorithms take vectors as their inputs, most of them, and you literally live in vector spaces. Some algorithms have got vector in their very name. So let's quickly see what these vectors are, what is meant by a vector, and how do these guys behave, some operations on vectors or something like that. So let me just draw this here, and let me say this is, let's say we've got this ray from the origin to this point A, and let me say the point is 3 comma 4 oh yeah. So, and let me call this u bar. So you've got this ray, so to speak, OA, and I'm saying this is a vector because anything that has magnitude and direction is a vector, right? And you see that this has got some magnitude over here, it's got some length, and it's got a particular direction, it's going somewhere up over here. So let's quickly see how do you quantify this and calculate this. So here, if you see, this is, if you drop a perpendicular here, it's just your x1, that is 3, and your y1, that is 4. These become the sides of the right angle triangle, and by Pythagoras theorem we know that it is x1 squared plus y1 squared. And if this vector was in an n-dimensional space, let's say a 3-dimensional space, you would continue with z1 squared and so on. And the direction is, an intuitive way of understanding direction is, if a vector is something with magnitude and direction, and if I just nullify the vector with respect to its magnitude, what's left is the direction. It's not a mathematical proof or anything of that sort, but just an intuitive way of understanding things, right? So let's quickly calculate this. So here you've got 3 squared 9 plus 4 squared 16 is equal to root over 25 is equal to 5, right? And over here you've got 3 comma 4, and each of them is u 3 comma 4 is u bar, and divided by its magnitude, which we just saw is root over 25 5, and this would be 3 by 5 and 4 by 5, which is approximately 5 30.6 40.8. So it's somewhere here, 0.6 and 0.8, right? So the way I interpret it is, if I travel from the origin towards 0.6 and 0.8, and if I continue to travel by 5 units, I would reach this point A, and I would actually become this vector u bar or OA bar, right? So let's quickly see another operation from for vectors, and let's say it's like, let's see addition, right? U bar plus v bar. So let me draw another vector here, and let me say it is v bar, and if I look at the points, let's say it is 5, and let me say it is 3, okay? So 5 comma 3, and let me say it's x2 y2. So here it's simply given by x1 plus x2 comma y1 plus y2, and 3 plus 5, x1 plus x2 is 3 plus 5, 8 comma 4 plus 3, 7, right? So this is your u bar plus v bar, and if you see 8 comma 7, so 8 is here and 7 is here, so it is somewhere over here, let me say, yeah. So this is your new vector. If I just drew a line from here to here, this is your 8 comma 7, and this is your new vector u bar plus v bar. And if you just drew this u here, since it's a parallel vector over here, you could just represent u by the parallel vector u bar, and you see that it is u bar plus v bar. You could also see what is u bar minus v bar, and this would be just x1 minus x2, y1 minus y2, 3 minus 5 minus 2, 4 minus 3 plus 1, right? So this would be somewhere over here 1 2, so here minus 2 plus 1, so it will be somewhere here. And if you actually just drew this, this would be your u bar minus v bar. Another way, if you drew a parallel vector over here, it would be somewhere like this, right? So yeah, so this is your u bar minus v bar, right? So here u bar minus v bar. So yeah, the next concept we'll see is projections, but probably we'll take it in a different video. Yeah, thank you.